In this video, we're going to explore how to model an MVVM Android app in Argo UML. We'll start with this quick overview, and then we're going to jump right into Argo UML. First of all, what is MVVM? When we started writing Android apps, we used the common model view controller paradigm, which is where we have model data, which is what we're representing, people, cars, money, nouns, things like that, living inside the activity. And it was living alongside the UI data, things like permissions and text colors and button clicks and the like. The trick is that this tended to make the activity a very big class, and it was hard to modularize it. So then we came out with Model View Presenter, which is where we kept the UI data in the activity, and then we had a separate presenter for the model data. And the idea is that they would work together, but be separate. The trick is it resulted in a lot of cross-communication between the activity and the presenter. So then we went to Model View ViewModel with live data. And the idea here is that the UI data stays in the activity as it has before, but then the data is provided as live data. So in other words, we're getting it maybe from some kind of external source, and the view model is simply presenting this live view of data to the activity. So that's what we're modeling here in this diagram. So if I want Model View ViewModel, I need to think about creating a user interface package with an activity or a fragment and a ViewModel class. But that's probably not all that we want for an Android application. We're going to need some way to persist data, to save data, to deal with data. So what if I want Retrofit? Well, Retrofit allows us to parse JSON easily and make it available into objects. So we need a DTO, which is an entity class or a noun class. You could even consider this like a model class. We need a data access object, which is a way we can get to data, and that will be an interface with annotations. And then we need a little utility class called Retrofit Instance. Now let's say that you want to store data in the cloud using something like Firebase. In that case, you're going to need a UI package with an activity and or a view model, maybe a fragment as well, and then a DTO, which DTO stands for Data Transfer Object. It's essentially a noun or something that we can save. So UI and DTO for Firebase. Now let's say that you want to persist data locally on the device using something like Room. Well, you're going to need that UI, as we've seen as a common thread through each of these. You're going to need a DTO, a data transfer object, a noun, something that can be saved. And then once again, you're going to need a DAO, a data access object, and this will contain an interface. And once again, we're going to use annotations on top of those interface methods to describe how we want to save and retrieve data. So with Argo, a few things that we're going to want to find. First of all, note the difference between an interface and a class. An interface, by definition, is simply a list of methods. And in the days of Java, we would use it as a variable type, but not as an object type. It's a contract. It just says these are the methods that you can call, but it doesn't have state by default. Since an interface doesn't have state, it doesn't need attributes, so it only has two boxes in its model here. It has the name, iSpecimenDAO, and then a box for methods or actions that it can take. It will also have this indication of the interface up on top. Now, an interface can be implemented by a class, and when we have implementation, we'll typically have a dashed line with a triangular box on top. Now here we have a class. The difference between a class and an interface is that a class can have state. It can have variables or attributes that tell us about that class or an object of that class at any point in time. So a class is going to have three boxes where an interface will only have two. And then if we're extending a class or subclassing a class, it will be a solid line and a triangle on top. So interface and then class, little description there. Additionally, it's a good idea to organize our classes that are similar into packages. So you see up here we have a package name. Package names are typically all lowercase. And in the preceding slide, I've given some hints on what the packages will be. UI, DTO, DAO, so on and so forth. So let's jump in and make a diagram. I have Argo UML up. Let's go ahead and make a new package. So I'm going to say com.myplantdiary.ui. So that will be our UI package. And then we can do another one for our DAO. Again, a common root of com.myplantdiary.dto. And then one more, com.myplantdiary .dao. And we could have others, but these will at least get us started. So in the COM Plant Diary UI, I'm going to go ahead and drop in a main activity. Each screen should either have an activity or a fragment. If you're not sure if you want to use activity or fragment just yet, don't worry. Just go to activity. We can always change that later to be a fragment. So this main activity will be the first one that the user sees when the user is looking at and maintaining a list of plant specimens. So I'm going to draw a little line over here, and we're going to call this one main view model. And that's what's going to provide a lot of the JSON-based data that we're going to use in our activity to show things like autocomplete text and the like. So ViewModel will typically come in one of two flavors. One is a pretty much generic independent view model that doesn't have any hard dependencies on anything else. And that's generally what we prefer, kind of like a POJO of a view model. But occasionally we also have to know about this thing called context, which tells us about our app. For things like GPS, we need context. So I might make a context-aware view model. Might make something like that as well, and we can tie that in. Okay, notice that the single line indicates uses our relationship, so this main activity uses both of these models. Okay, now the DTO package. This is where we think nouns or traditional classes in Java. I'm going to have one called plant, and that represents the scientific definition of the plant. So I could do things on here. No, let's not worry about operations, but let's go up here and let's say genus string. So we're thinking about the scientific way we define a plant. We have a genus, we have a species string, and we'll have things like common name. So I can right click and I can choose add, and we'll say attribute, and maybe we'll call this one common name. And then we'll give it one more. Let's go ahead and right click and we'll say add a new attribute, and we'll say plant ID, int, enter long. Now this is data that's going in one of two places. This is data that we could be bringing in via Retrofit and showing this for autocomplete data on our main activity, which indeed is what we plan on doing. So I'm going to draw a uses a line between this plant and our main view model to indicate that the view model is going to be consuming this. But if I'm going to use Retrofit, I know I need this DTO, and I know I need one other thing from the presentation we just saw, and that's a Retrofit client instance. Now, I struggle a little bit on what package to put this in. It's essentially a utility class that's just getting Retrofit up and running. We could put it in a utils package, but I try to avoid that because that becomes a garbage dump if it gets too bloated. For the moment, I'm just going to put it in UI, but we could possibly think of other places where we could use it. So Retrofit client instance. And once again, we can, if we want, we can draw a line up here to indicate that the main view model is going to be calling into that Retrofit client instance. Now, for Retrofit, we need one more thing. That is, we need an interface that we can annotate and describe how to go get the JSON data. Remember, an interface is this two-box model here. So we'll simply call this one iPlantDAO, like so. And we will draw a solid line between iPlantDAO. Actually, no, I'll tell you what, let's just leave that as that is for the moment. One weird thing is that we typically will implement an interface with a class, but in this case, Retrofit handles that implementation for us. All we have to do is define the interface and the methods. Retrofit takes care of the rest. So the plant data. Plant data is something we're going to use as a lookup. Like, I have a redbud tree, so I want to start typing in redbud and have it autocomplete Eastern redbud Cercis canadensis. My neighbor might have a redbud too, and there might be a redbud at UC. So this concept of a plant is what ties all of these individual redbuds together. But we need to model the individual redbuds. So for that, let's have another class, and we're going to call this one specimen. So the idea is that a specimen is a specific plant that we can touch somewhere. So this is going to have different attributes. It's going to have things like latitude, which is specific to that plant. We'll make that a string, although some people make it a double or a float. We'll talk about why we do that when we get into GPS operations. Let's add another attribute. We're going to call this one longitude. Okay, and this one will make a string as well. And then we'll add a couple more. We'll go add new attribute. And let's make this one plant ID, because the idea is that we're going to be tying back to the plant ID. But on the same note, we're going to need a specimen ID, something that makes this specimen unique. And then maybe we'll say notes string, some kind of notes. Okay, so this specimen is something that the user creates. So that's a read and write concept, where the plant is something that we're just looking up. So for the specimen, we might also need another kind of activity. We might need like a specimen detail activity, something like that. So I can come down here and I can say specimen detail activity. And then we can draw a line between these items to indicate the uses of relationship. Let's say that we want to store specimen in Firebase. If that's the case, we're all good at this point. We simply need to define that DTO, and then we can set up some Firebase methods. Firebase, again, cloud database, cloud storage. We need to set up some methods for Firebase, and Firebase essentially handles the DAO for us. Now, if we want to persist this locally, we'll need to make an interface for room database here in our DAO class. So we'll make this one iSpecimen DAO. And once again, for room, we only need to create an interface with methods. We don't actually have to implement those methods, which is actually kind of cool. So that's all we need to do, just leave it like so. Now, just like we had Retrofit client instance as a bootstrap class for Retrofit, we need a bootstrap class for our room database as well. Once again, I'm debating where to put this, which package to put it in. Probably makes the most sense in our DAO package because it is a persistence class. But what we'll do is we'll have room database, and we actually will extend this. This is something we'll put out here because it's provided for us. We will extend that into our own class, which we might call plant room database, or we could call it app database too. Something like that. Nonetheless, with this diagram, you now see just about everything that we would need to model a simple model view ViewModel Android application, one that uses Retrofit, one that uses Room, and one that uses Firebase. If I want to put this into a design document, first of all, I'll save the project. Just a good idea to save the original source. We'll save this as plant diary, like so, and save. But then we can also export graphics, and that will allow us to take just this diagram and, yeah, we'll go ahead and do like so. It'll allow us to take just this diagram and export it as an image, and then that image we can put into a design doc. So I hope this video has been helpful, and I look forward to reading your comments. Thank you.